Good morning, YouTube. How is everybody out there doing? YouTube seems to have let me get through on the first shot here. All right, so I'm Greg from GregsTutoringNYC at gmail.com. We're on part 17 of our SHSAT-like ISEE problems. We have about 68 more days until the first SHSAT day. And for anybody who's following us to watch the ISEE, I think that's either September 7th or 14th. I can't remember which. So those people have about 3 weeks. You got 21 days versus 60-something days. We're at what I'm calling SHSAT 9 for this. We're at some of the more advanced problems in this sample test from the ISEE. By the way, there's a link to the bottom in the description to this document that I'm using. Some of the stuff if there's a link, I give it. If not, it's usually material that I developed myself, or it's from something like the SHSAT handbook, which is obvious. So we're going to just keep chugging along here, guys, and see where we're going. I'm going to go maybe a little on the hour. Let's see how many problems we have, and I'll just pace it out. And there's probably going to be one more part after this, and then I'll figure out what to do after that. This has taken a few weeks to do, longer than I ever expected, to be honest with you. And there's still tons of more examples, including examples that are not on this test at all, and also examples that I never covered in any of the other YouTubes I did. On that note, by the way, this is a lot of work, a lot of hours. I put up hundreds of hours of YouTube stuff, I'm certain, all for free. So please like and subscribe so we can proliferate the channel and get it into the hands of other people, other kids who are also taking either one of these tests or similar tests. A lot of the tests are similar at certain levels and different at other levels. As well, you can email me. My email is at the bottom there. Of any questions whatsoever at all on the SHSAT, the ISEE, or any other test, whether it's about a particular problem, a specific math problem, a specific English problem, about the topic list, about how to approach taking a test, or just things about registration and stuff like that. When is it going to happen? And all this. There's a lot of procedural things that need to occur for the SHSAT and for the ISEE as well. And by the way, if anybody's taken the TACHS, I'm going to do YouTube of that soon, but the registration for that's going to start coming up in about a week. All right, which is the Catholic high school test, at least in the diocese of New York City area and Westchester and stuff like that. All right, so let's jump in here. I think the last thing we did here. Let me put me behind the behind this. Let's see here. Give me 1 second so I can get rid of me from the questions. Let's see. All right, that should work. Pull me over so I can see my big giant head. And let's scroll down to the next question. Okay, so our next question is 25. Let me just make sure the screen is set up for you guys and also that the stream is actually live. All right, so we seem okay. So again, these are supposed to be SHSAT 9 level questions. If you're taking the SHSAT 8, hang on anyway, because you should be doing these problems. Right? We're taking the position that SHSAT 8ers should do all 8 and 9 tests, and SHSAT 9ers should also do all 8 and 9 tests. And if you don't understand why, you can watch some of my other videos where I explain that, or you can email me. All right? All right, so here's our question. Whoops, it's not showing completely. Give me 1 second. All right. So the graph, so we have an illustration. So when I begin to read the words, we have summer reading. Bottom, the x-axis says the number of books. So we have the range, the number of books is going from 1 until 6. We also have the number of students. So it means, for instance, 1 student read 4 books and 6 students read 5. And there's probably some total they're going to make us do here. Maybe figure out the mode, maybe figure out the range, maybe figure out the median or the mean/average. All right? So there's not much we can do here with those numbers, but just make sure that before you go to the words that you are 100% about what the chart is about, and you can ask yourself questions like I did. Like, how many students read 6 books? 5 books, that would be 6. How many read 7? None. Okay? All right. So let's go to the words. The graph shows the number of books read by the students in Miss Show's class last summer. All right. So that confirms with what we just observed. Okay. So we're done with the first sentence. They're really not giving us any deets there. Okay. The numbers on the horizontal axis. The horizon goes this way. When you look out at the horizon, it goes this way. So that's horizontal. This is vertical. Vertical's up and down. Horizontal's laying across. So it says the numbers on the horizontal axis, which is the x-axis, represent the number of books read during the summer. And the height of the bar, which is the vertical one going up and down, represents the number of students who read this number of books. Okay? And the question is, what is the mean number of books read over the summer? Okay, that's a little chopped off. I'm going to leave that chopped off so we have working space. There's not enough working space on the camera here. So, and there's not enough working space to fit on the screen as well. So if I shift things over, things will get teenier. So this seems to be the good balance. All right, so what is the mean number of books read over the summer? So this is about interpretation of your charts and things like that. So a solution a lot of kids are going to do is 5 plus 4 plus 2 plus 1 plus 6 plus 2. Okay? So some kids are actually going to order these. So you're going to have 1, 2. You have 2 twice. So you're going to put 2 twice. Then they're going to have 4, 5, 6. And they're going to do this thing like this. They get the middle of that. And say the mean is 3. Well, first of all, that's the mode. First of all, that's the median. And it's not the way to do the median. Okay? And then, so then that's wrong. There's another set of kids who are going to add this up. And I like to do things by 10 as a number sensing. So that's 10. I get 5, 6, 7, 8, 9, 10. So that seems to equal to 20 if I did that correct. And then they're going to do 1, 2, 3, 4, 5, 6. And do 6 into 20 and get 3 point something. That kind of works, but it's not the thing here. And by the way, we're given A, B, C, D answers. So let me show that just so you can get a sense of what's being looked for here. In fact, maybe that'll fit on the screen that way at this point. Yeah, it does. Let me just drag this down slightly. Right, so we don't need the top anymore. What we really need to do is add up every single thing here. So there's 5 ones. Okay? There's 4 twos. And be careful doing this. There's no 3s. Or there's no height 3, rather. 4 twos. Then there's 2 3s. There's 1 4. There's 6 5s. And there is 2 6s. Okay? So you have to have this done right, whether you create this list this way or do it another way. So let me just make sure it's right. We have 5 1s, 4 2s, 2 3s, 1 4, 6 5s, and 2 6s. So really what we're going to do is total these up. Okay, so I'm going to do this by tens as well. 30, 42, 50, 60. I believe I got 65. I'm going to do that backwards just to check. So we have 13 plus 6 is 19, plus this is 23, 33, 43, 53, 63, 65. And we have 1, 2, 3, 4, 5, 6. So we do not divide this by 6. We have to probably use this 20. All right, so I'm going to double check that that 20 is right. The number of students, right? This is the number of students. We have 5, 4, 2, 1, 6, and 2. So let's do today. We got 9, 10, 11, 12, 18, 19, 20. Right. So now we're going to have 20 divided into this number here, 65. Okay, this is normal. This is the normal way we would do an average. We're getting the sum of the numbers over the number of numbers. This is the sum of all the numbers. If you add up each specific student with the number of books they have, you'll get 65 books were obtained all together by the students over the summer, and there's 20 students. So 2 goes into 6, can't do. Goes into here, we get 60, so we get 5 left over. We carry up our decimal point. A lot of you used to long division. This is short division. 20 goes into 50 twice, so we get 40 minus, we get 10 left over, and 5. So my answer is 3.25, which is B. What question number is this? 25? Yep, 25 is B. All right, so let's make sure the stream is still going. YouTube is always slapping me around here. All right, so this question's weird in the sense that you were kind of taught this in grade 5. So why am I saying this is really a grade 9 problem? Because the truth of the matter is a lot of you are going to get this wrong. I'm going to guess as many as 50% will get this wrong. Or you're going to take too long to solve it. You're going to make a mistake some here, and you're not going to get any number at the end that matches the A, B, C, or D, and you're going to have to redo it. And if you noticed, I added up my numbers here twice, and I added up here twice. So be careful. These are the 2 places you're going to go wrong. So 1, 2, and then over here where you actually do the division is where you might screw up as well. So remember, mean means the average, and the average means the sum of all the numbers divided by the number of numbers. All right? And this is one of those problems where almost, I'm going to guess 50% of the kids are going to make a silly error. So part of mastery of math and being even an astute and accelerated intelligent student is attention to detail, right? So this is one of the questions where I say hard questions are hard and easy questions are also hard. This is one of those kind of explanations there. So there you go. And what you want to make sure is you're pacing on something like this, because there was a lot of calculations to have to happen here. There's probably 15 calculations you had to do to solve this. All right, so let's go to the next question. Make sure that's showing on the screen. It might be cut off. No, it's not. But it's too high. Let me just adjust some of this because I want to make sure we're using the maximum amount of space on here. Okay, 26. And there's a lag here, so I can't tell what's catching up on your guys' screens or not. Okay, so a solution set is graphed on the number line shown. So we have this weird-looking thing, and it says the solution set of which inequality is shown. So there's a few ways to solve this. So first of all, we have some number line that has something like this in it. Okay? So first of all, we have to look at the number line, right? We're going to look at the illustration first. We notice it appears to go from -7 from 1. Okay? From -7 to 1. And it doesn't include -7 and 1. Right? A solid bullet means it includes it. So we would have a greater than or equal to or less than or equal to on either one of these. Okay, but since it's full, we only have less than or greater than's involved here. All right? So that's what we're learning from this without even knowing anything else about the problem. Even if I didn't even show you the 7 and a 1. We know since these are open holes, as if a bullet shot through them, right? And this is solid here. So we know our deets are in here, but the deets don't include the endpoints. All right? So something is happening there. So we notice again we have -7 to 1. We don't know what's happening there. And so there's not much more we can get out of here. This is like that. So let's go back to the problem itself. A solution set is graphed and the number line shown. Okay, cool. So, and then it says the solution set of which inequality is shown. So there's a few approaches to take on this. So one approach is brute force. So let's try the brute force approach and see where it leads us to. So I believe we covered this a few problems ago, what something like this means. So there were two ways to do it. We either split this to plus or minus, or we split this to plus or minus. All right? So we're going to get something like x minus 4 is less than 3, and also minus x plus 4 is less than 3. Again, we're gonna do the plus of this whole thing and the minus of this whole thing. That's what we're talking about. So we get x is less than 7, right? We just add 4 to both sides. We subtract 4 from both sides over here. So we get minus x is less than minus 1. And then we divide by minus 1, so we flip the sign. So x is greater than 1. Okay, so if we map this to our problem situation, where we had minus 7 and 1, this doesn't map that. This says x is less than 7. Well, that's over here. Okay, and it says x is greater than 1, which is also over here. So it seems like A is not the solution. So let's try B. So we have x plus 4 is less than 3. So we do the plus minus thing. So we get x plus 4 is less than 3. We subtract 4 from both sides. So we get x is less than minus 1. And we do the opposite, which is minus x minus 4 is less than 3. We add 4 to both sides. We get minus x is less than 7. We divide by that. Minus 1, we get x is greater than 7. Okay? So again, that's talking about here and over here. So B doesn't match it either. Okay? So let's go with C. C is x minus 3. And there's a point for me doing all this. First of all, if you have no choice, you brute force it. And we're also demonstrating how to solve these inequalities still. Okay? So we have x minus 3 is less than 4. So we're going to add 3 to both sides. We're going to get x is less than 7. And then we get minus x plus 3 is less than 4. We subtract 3 from both sides. We get that. And we divide by minus 1. We get x greater than 1. So again, if we come back to here with x less than 7, that's still not those bullets. So we tried the other 3, so D has to work. Otherwise, we made a mistake. So we have x plus 3 is less than 4. So we get x plus 3 is less than 4. We get x less than 1. And then we get minus x minus 3 is less than 4. We add 3 to both sides. Minus x is less than 7. Divide by minus 1. X is greater than minus 7. Okay? So this turns out to match that. Again, we're shooting for 1 and minus 7. So this doesn't include them, so the holes match. And we're getting the midpoint in here. So D actually works. So the pro of this was I'm helping you guys and showing you guys more about how to solve these kind of inequalities. And by the way, there's still the flip way where I could have solved this as x plus 3 is less than 4 and x plus 3 is less than minus 4. Right? That's the alternate way to do this, and it'll still give the same answer. All right? I just prefer this way, but you could have done this for each one of these. Again, going back to the top, I did it this way. You guys can do it that way. And you can do it both ways. At the end to confirm, once you think you know the answer, try it the other way and see if it jives. So, so the pro of that was getting experience, but when you're taking the real test, you don't need experience. You need to get the damn answer. You needed to get the damn answer quickly. All right? So you might say, how else can we do this? Well, if we take the choices, because we have these, I'm going to just write them down. You can kind of play around with this in your head, and you're probably going to goof up. So on a problem like this, alongside the questions, right? This is A, B, C, D. You can start doing stuff. So we know there's a version on all these where we basically throw away the absolute value signs. So why don't we just work with those? Because there's nothing else going on here, right? So if we add 4 to both sides, we get x less than 7. Well, that's not the graph, okay? Yeah, minus 7 to 1 is less than 7, but it's not the endpoint. So A is gone. So do this one, okay? X is less than minus 1. If we subtract 4 on both sides, okay? No. Yes. So that one might be it, okay? If we add 3 to both sides, we get x is less than 7. Again, no good. And if we do this, x is less than 1. Oh, wait, sorry. It was 1, not minus 1. So this is gone. So the only one matching so far is D. And then at this point, we can try the other one, which is the minus x plus 3 is less than 4. And we already did that. Or if you want, x plus 3 is less than minus 4. These are both equivalent. Okay? So you can just rapidly go through these and figure out which is it. First of all, some people can just look at it and go, bing, that's it. But this is a fast, super fast way to do it. So they're not doing all that other work. So what you're trying to do is find the 1/2 that matches, which would be this, that x was less than 1. And then you want to run it through to make sure the other side is greater than minus 7. All right? So there you go. 27. How we do it on time here? We're about 24 minutes in. Okay. So the point of showing you the alternate for 26 was to show you a faster way to do it. Okay. And no matter how you solve it, toss in a double check. You know, if you do it this way, then do it this way. If you do it this way, then do it that way. You can also plug in a number. Plug in some numbers. In fact, that's the other way to do it. So if it's showing you the end caps, where you have 1 and minus 7, and then you know the expressions, just if you do something like x is 0, throw it in and see which one works. And if more than 2 works, then hone the numbers down. You can go to minus 6, and you can go to, something close to 1, which in this case would be 0. So just figure out your ranges and plug numbers in. So it's an alternate version of doing brute force. So that you have 3 ways to do it, okay? Including when you know the answer is D. Once you know the answer is D, throw one of them in there. For instance, in D, if x is 0, then you have the absolute value of 3, which is 3 is less than 4, and that's true. All right? So you've confirmed it through multiple mechanisms that is indeed the case. Okay, 27. All right, 27, I do not like this problem. Let me shrink this slightly. How can I get this going right? 1 second here, it beeps. Okay, I'm going to drag this over here. Okay, I need to shrink it down once. Blah, blah, blah. Let's see here. Will that work? Yeah, that works. All right, so this is a nasty problem to me. And it was one of the ones on this whole test that I kind of did a double take on. So let's look at the chart for starters again, my usual modus operandi, and see where we're going on some of this. And this is definitely a grade 9 SHSAT question. just because I think it's cryptic, okay? Wait, YouTube just gave me a warning. Give me 1 second, guys. And it went away. YouTube! Okay, so the chart shows something about a coin toss. So let's assume we have a quarter. And that's a coin, and we're flipping it, I guess. So apparently the coin is being tossed a number of different times. All right? I guess from no times to 3 times. So they're showing us, based on the number of heads, what is the probability that a certain number of heads will come up, from 0 or 1 or 2 or 3. So this is kind of cryptic and confusing. Certainly it was to me. Again, this is probably the hardest problem on the test for me. And it was because at first, I didn't know where the eighths were coming from. Because I know when you do permutations and so on, if you're, and especially when you go back now to the words, a coin is tossed 3 times, the table shows the possible outcomes and the probability of each outcome. What is the expected number of heads? Okay? And it's kind of a couple questions buried here, at least in my mind, going on simultaneously. And part of it's a red herring, it's a distraction. All right? They're kind of setting you up. So, because first I was like, wait, do they mean the statistical probability theoretically? Or do they mean they actually did tosses and this is what they came up with? And then the question was like, wait, does the eventual question actually tie into the table or not? All right? So it's kind of weird. So there's kind of 2 answers to this. If you read it deeply, clearly, and concisely, it says, what is the expected number of heads? Well, if you have a coin and you toss it, it's 50-50 whether it's heads or tails. So if you toss it statistically 4 times, it should land on heads twice, right? And tails twice. And if you flip it 2 times, it should probably land on heads once and tails once. And we know that's the statistical probability, but the actuality is you might toss it 1,000 times, and it only lands on heads. But the expectation is every other time, because it's 50-50, and we're assuming the coin's fair, that it was machined correctly, and there's no weight on one side, and one side is head and one side is tails. It's not like both sides are heads or something like that, right? So if you toss it 3 times, then 1.5 times is the number of times it should appear as heads, which becomes awkward because you're like, wait, it can't be 1.5 times, because that means 1 time it landed on the heads, 1 time it landed on tail, and the other time it landed on the side of itself, and that's not what statistical probability is about, though. All right. So the answer is B. The answer is 27, which is B. All right. So then we get into the question. Well, what are they really talking about here? How does this table even come about? Because there might be other questions involved with this. It might be we spend the whole rest of this video talking about this question. So there's 3 choices: heads or tails, heads or tails, and heads or tails. So the number of combinations, because it's heads or tails, cubed. So it's really 2 to the 3rd, which is 8 choices. All right, we can write this out kind of as a binary thing where, or let me use heads and tails. So it would be tails, 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 heads, tails, heads, tails, tails, heads, heads. So that's 4. So we're going to get tails, heads, heads. What do you get? I wanted that to all fit all together. Heads, tails, tails, heads, tails, heads, 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 tails, and heads, heads, heads. All right? So we get 1, 2, 3, 4, 5, 6, 7, 8. I got 9 somehow. What did I do wrong? Did I write 1 twice? That's why I want to do 0, 0, and 1. Yeah, I wrote this one twice. So be careful when you're doing this, guys. I would have preferred to just use 0. I'm used to counting in binary. I used to be a computer programmer. So these kind of things make sense to me. So let's try to figure out where the thing on the table is coming from. So it says if the number of heads is 3, that's only this case. And that's 1 out of 8 of them. All right? It also says if none of them are. So this is also 1 out of 8. So it says the number of times there's 2 heads is here, here, and here. So these 3 create 3 eighths. And the number of times there's 1 head is here, here, and here. So that's also 3 eighths. All right? So that's where they're getting these probabilities from. And by the way, we can also do some of it, for instance, like, so if I flip a coin 3 times, the chances it's heads is a half. If I flip it a second time, its chances of heads is a half. And if I flip it a third time, its chances of heads is a half again. Well, that's equal to 1/8. So we have multiple ways to confirm the math here. Okay? So that's where the chart's coming from. So just in case you're unsure about that, that's really what the deal is talking about here. All right? And then what is the expected number of heads? We still end up that it's 50-50. And we're going to have a combo because if this is the probability, by the way, we can do stuff here because the probability of it landing on tails is also a half. So that's where the 8th comes in for all of these, by the way. All right? So just keep some of that in mind when you see a table like this where you're like, wait, the number of heads is 50-50. This, you have to go deeper than that, use the 2 to the 3 and build a little table. And hopefully there's not 100 permutations here. But even if there is, you can still figure it out with the math. Okay? There's probably some way to make a connection between that and the 3 halves. Let me see, actually. Because we have how many involving heads? That's 1, 2, 3, 4, 5, 6, 7, 8. Wait, how did I get 8? 1, 2, 3, 4, 5, 6, 7. We got 7 eighths. Nah, I'm not sure how that deals with it. Because every one involves heads except for this one here. There's probably a connection. Somebody can put it in the comments. If they see it, it'll be helpful. My brain is dead at the second. Okay, 28. 28 is one that comes up all the time. You could even see this on a grade 8 test, but it creates its own dilemmas. Let me try to get a clean piece of paper because this is the kind of thing you want to do right. This deals with unit conversions. Sometimes it takes different shapes, especially on the SHSAT, because they can give you mythical things. Here we're using realistic numbers. So there's 2 things to be concerned about with this problem. First of all, it gives you a word problem, and it gives you a bunch of choices. So first of all, it's just plain old getting the answer in the first place. The second thing is sometimes the answers are not in the form that you would have put it into. Okay, so you have to watch out for that. So just looking at some of the answers without looking at the question yet, I see each one has a 400, each has a 60, each has a 3.305, and each has a 5280, and they all consistent one way or the other. So that gives me a little comfort that this is probably straightforward, because normally it would be uglier if they wanted it in a different form. In this case, and by the way, they don't want it simplified. They just want to see that you can go through the right steps to get this right. So, and this is one of those ones where you have to be delicate on it again. You really have to be delicate. So let me see if even I make a mistake. So there is 0.305 meters in a foot. So let's just start with what we're giving. They're at 5280 feet in a mile. And by the way, this one you should know already. You should know what that is. A horse is traveling at a speed of 400 meters per minute. And the gotcha here is I don't want to put mm, so it's meters per minute. You have that kind of thing, you want to do that. Which expression has a value equal to the horse's speed in miles per hour. So we want to get this in miles per hour. Miles per hour. So we want to convert minutes to hours, basically, and also meters to miles. Okay, so let me just make sure I have the numbers right. 0.305 meters on 1 foot, and 528 feet in a mile, and a horse is going 400 meters per minute. Okay, so that's really what we want to do. We want to start out, sorry guys, that was cut off. So here we have our givens. Okay, we want to do the conversion from minutes to hours and meters to here. And obviously in some process we might be converting that 400 as well. All right, so we have 400 meters per minute. So what I'm going to do is I'm going to drag this across because I don't see any other way to do it so that I can give you guys the right solution going across the page. So I'm going to drag the answer sheet over. In fact, I might bring it down lower. Can we do that? Let's try that and see how far that lets us go. So I want to get things in this here. So basically we're going to take the units and try to flip-flop them. So there's 60 minutes in an hour. Okay? So not only are we going to cancel out numbers, but we're going to cancel out units. So this minute kills that minute. So now we have meters per hour, but we need to get miles per hour. Okay? So we know that 1 foot is 0.305 meters. So now we cancel the meters. So we're left with feet over hour over hours. And then we want to do miles, 5280 miles over, sorry, I did that wrong. 1 mile over 5280 feet. So the feet are going to cancel out. So we're left with miles over hours, and that's what we wanted to get. So we should have 400 times 60, and that fell off the screen, didn't it? At the end? No, it didn't. 400 times 60 miles over, this goes away, we have hours, and we have 0.305 times 5280, and that should match, it looks like it matches A, and I hope my answer is A. Yep, 28 is A. So just take this one step at a time. If you notice, I almost goofed this one up. So just take your time. What you're trying to do is cancel the units. When you get matching units, then the numbers will just follow it. So just try to cancel the units out, and just whatever number matches what that should be, just make sure. Make sure you're putting it right, like I did here. Because 5,200 miles is not a foot. So one mile is 5,280 feet. All right. So, getting back to my original comment, sometimes this is not the form they give it into. They might cancel some of these out, the numbers themselves as well. All right. So what's also good is they told us the answer was going to be in miles per hour. All right. By the way, if you notice in the answers, they left out the units because they're telling us in the question that it is miles per hour. All right. All right. So we're pushing up there on time. Let's see what else we got here going on here. All right. Let's do 29. So Alan measures the height of a pole to be 3 foot and the height of a shadow of the pole to be 5 foot. So you guys would already have this on your test book. So this is the shadow. This is the pole. So he measures this to be 3 and this to be 5. Okay? So we want to look at the illustration first. Looking at this, you tempted to say there's something about a triangle here, and this would be 4. But this is not a 3, 4, 5 triangle. 3, 4, 5, the 5 is the hypotenuse. So we just want to look at this to something 3 foot and something here. We're not even sure that it's a shadow problem yet, but we know from the words that it was. And they have a shape here. We're not exactly sure why yet because we haven't read the question. Okay. So sometimes they may want the volume of this depending on something here. We don't know yet. Okay. So we just know there's 3 and the 5. And they're in feet. So it says, Alan measured the height of a pole to be 3 feet and the length of the shadow to be 5, as shown in the diagram. At the same time, the shadow of a tree is 20 foot in length. So there's some sort of tree, and its shadow is 20 feet. Okay, what is the height of the tree? So this does become a similar triangle problem, because if we work from the top of here to here, then this angle and this angle are the same, and this angle and this angle are the same, and we're pretty cool that this is a right angle. Okay, and even if it's not a right angle, it's the same matching angle, because we're assuming the sun is in the same position. Theoretically, it's not, because this will be slightly over. One of the other two is going to be slightly. And even if it's the center, the shadows won't fall exactly literally the same. But since they're similar triangles, the ratio of the sides are going to be the same. So we can go 3 is to 5, as x is to 20. We can do the cross product and get 60 equals 5x, and then x equals 4, right? I did something wrong there. 60 equals 5x. 60, I wrote 20. So x equals 12. Okay, so that's doing numerically. We can also just observe that this is times 4. So this must be times 4. And we would get 12 there as well. So the answer for 29 should be B. Yes, sir, it is. Let's do one more and then call it a day. So what is the most reasonable unit of measure when measuring the length of a leaf? Okay, so this one is just an arbitrary one thrown in. It's definitely not grade 8 or 9, it's lower than that. But a lot of this doesn't come up often, so they just end up throwing this in here. This will most likely not be on the SHSAT, but they may ask something where they give the answer in units. So on the SHSAT, there might actually be a computation involved, where they'll say like 12 centimeters, 12 grams, 12 kilograms, 12 meters. So centimeters is a length, grams is a weight, C is a weight, D is a length. So we're choosing between centimeters and meters. We can measure the length of a leaf in centimeters or meters, But it's the same as, would you measure a leaf in yards? Not unless it was like from Jurassic Park, right? So a normal leaf that's about the size of a hand, we would normally in America use inches or centimeters, okay? So the answer to 30 would be A. And just because it's still on the page, how about 31? Which numeric expression does not represent an integer? So this one's kind of a no-brainer. And by the way, this is one of those questions where once you get the answer, you can't feed it back into the problem. And what it means is you actually have to go and compute each one of these. So the square root of 4 is 2. So for A, we're going to get 2 minus 5, right? So that's equal to minus 3. That is an integer. A negative number is an integer. B is going to be 2 times 5. So that's equal to 10. That's definitely an integer. C is going to be the square root of 21. And that creates an irrational number, which is not an integer. Okay, and just for completion, 4 times 25 inside of here gives the square root of 100, which is 10, which does. Okay, so our answer here is C. All right, so again, we can't feed this into the question. So this one, you actually have to go through all the choices. And by the way, notice what I did here. I detected that the answer was C. I did D anyway. A lot of kids will get like the answer at A, and they won't check the other choices. And then, by the way, that's part of your pacing decision, because if you check every choice of every question, you're spending time. So what you want to do is master all the questions and all the kind of problem sets and all the curriculum that they're asking you to do here and try to match it up. All right? Okay, we're done. Let me just make sure the stream is still going. All right, everybody. Happy Sunday, 68 more days. I'm Greg from GregsTutoringNYC at gmail.com. Please like the video. Please subscribe. I got a ton more stuff for you guys. And email me any questions. Peace out.